Hey kids, I'm excited for you. This is going to be a great lesson. We're moving along in chapter 6. Today we are going to graph inequalities that involve two variables. So as we go here, this is going to feel like writing and graphing equations in slope-intercept form, only they're not equations, they're inequalities. And so that's the subtle difference between the two. If you can make that clarification in your mind before we get started, that might benefit you quite a lot. So in order to graph, back up, disclaimer. I'm going to do my best to explain this clearly and not get ahead of myself. But other math teachers might do this differently, and that's okay. This isn't the most thorough and complete lesson. It's the high points, so that my students can be helped from home in case they're absent or need a little extra help when I'm not around. So now we can jump in. To graph a linear equality that has two variables, here are the 5 steps that we are going to follow. We'll first write the inequality in slope-intercept form. We will plot the points for the y-intercept and the slope, but don't do the line yet. So that's like getting graphing an equation in slope-intercept form, just not drawing the line. Now, before you draw the line, you need to consider, was it greater than or less than? And if so, it's a dashed line. Or was it greater than and equal to or less than and equal to? And if so, that's a solid line. And then you will shade the appropriate half plane. This is the most important thing for you to note to save yourself some trouble. If it's greater than or greater than and equal to, you shade up, not right. Sometimes it also happens to be right, but it's not right, it's up. And shade down for less than or less than or equal to, not left. Again, we're not thinking horizontally, we're thinking vertically up and down because y is our leading variable. So y equals mx plus b. Okay, the y value is up and down because that's the y-axis. Then we're going to check our work by choosing a point from the shaded region to sub into our original inequality. Okay, so let's try that here. We have x and y is greater than 3. Well, we need y equals mx plus b. X is on the wrong side. Move it with a negative x. What I do on one side, I do to the other. Y is still greater than, because I didn't multiply or divide by a negative, greater than negative x plus 3. Okay, so that is step 1. Step 2 is to plot the points for the y-intercept, which is positive 3, and for the slope, negative x is negative 1, down 1, left 1, or right 1, I'm sorry, or up 1, left 1. But we're going to stop. We're not going to draw the line yet. Because this is greater than and not greater than or equal to, we're going to use a dashed line. So using a straight edge, please don't just wing it. You can find a straight edge anywhere. I ripped off a set of post-it notes from my fridge. All right, there we go. And this is our line from one side of the coordinate plane to the other. And then we're going to shade the appropriate half plane. That's step 4. Because y is greater than this line, I'm going to go to a couple of my points and draw an arrow that goes up. So here, and draws an arrow that goes up. This seems like a really simple step, something that's almost insulting your intelligence to actually have to draw an arrow. But drawing those arrows really does prevent a lot of issues and errors. And again, notice that I shaded up and down, well, up instead of down rather than left and right. And then that's the section that we're going to shade. Shade, 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 shade. Okay, so what that represents is any point that is in the shaded region will satisfy our inequality. And let me please show you what I mean by that. I'm going to scoot down here. I'm going to go actually clear down here. So let's pick a point. I like to pick points that involve zeros because it's easier to substitute them in. 1, 2, 3, 4. 4 and 0. Remember, a coordinate is made up of an x and a y. So x, y. 4 plus 0 is greater than 3. I put x, 4 in for x, 0 in for y. 4 is greater than 3. And I could repeat that checking process with all of the points over here, even halves and partial ones. So let's backtrack a little bit. Because the inequality is greater than where you're going to shade up, that's us, up, and we're going to use a dotted line. Okay. All right, let's try another. It occurs to me that we're zoomed in. That might be a little bit easier. Okay. This next one's going to be pretty great. It's going to bring together almost everything we've done this chapter so far. So, it says first to graph the inequality. Well, first we need to rewrite the inequality in slope-intercept form. So, it should be y equals, or, well, y inequality sign. So that means the 3x needs to move to the right. What I do on one side, I do the other. So negative y is greater than negative 3x plus 4. I need for this negative y to be positive. And to do that, I would be multiplying by a negative 1, which would flip my sign and make negative 3x into a positive 3x and a positive 4 into negative 4. And now my inequality is in slope-intercept form. My intercept is at negative 4. My slope is 3, so 3 over 1. And is my inequality going to give me a dashed line or a solid line? Dashed, because it's just less than, not less than or equal to. And so I'll make my dashed line. And I'm going to shade up or down, not left or right. Y is less than. So I'll find a couple points and arrow down because it's less than. This is my shaded region. Okay. Let's recap a couple things before we get too far ahead. Because the inequality was less than, we shade down from the dotted line or dashed line. And we can prove that we are correct by picking a point. Go easy on yourself. This one's 2, 0. So I'll use 2 for x, 0 for y. So 3 2's minus a 0. Is that greater than 4? 6 minus 0, which is 6, is greater than 4. That's correct. And so I can prove that I shaded the correct region. All right, let's try another one. Isn't this fun? I like this one a lot. Okay, here we have another inequality. It has an x and a y, so x should be on the left side. Move it over. So 6y is still less than or equal to, variable comes first, 12. We want 6 to be alone, so we'll divide by 6. We divided by a positive, so I don't have to flip the sign. Remember to divide everything on that side by 6. Okay, my intercept is positive 2. My slope is negative 1/6. Okay, and then am I going to have a solid or a dashed line? I'm going to have a solid line because my solution can also include anything that is on this line. If I had a ruler, this would be a better line. That's kind of a bad line. Okay, and then I will determine if I'm going to shade up or down from the line. Y is less than is below. And so this is the region that we are going to shade. So because the inequality was less than or equal, we shade down. And it's from a solid line. And we can prove that we're correct by choosing a simple point like 0, 0. It's my favorite one when you can get that in there. Use 0 for x and y. Is it true that 0 and 6 zeros are less than 12? 0 is less than, 12. And so I can prove that I shaded the correct region. Great. let's talk about a couple what-ifs that we've actually already talked about in graphing equations in slope-intercept form. But let's see if you remember these subtle differences. What if I have just a y is greater than? Because this lesson is on 2 variables, but this only has 1. Well, what if that said y equals 3? If you have a y equals, what kind of line is that? Horizontal or vertical? It's a horizontal. No matter what x is, y is that. And so this will also be a horizontal inequality. What kind of line am I going to draw? Dashed. Okay, and it is greater than 3, so I'm going to shade up from 3. Great, because the inequality is greater than, we shade up from the dashed line. All right, let's try this next one. This one has a couple tricky things, so be careful. If I want x by itself, to get x by itself, divide by a -3. And when I do that, because I divided by a negative, I'm going to flip my sign. Okay. Now I have x is greater than or equal to -4. Knowing that x and y are opposite axes and that y makes a horizontal line, it's totally logical that an x in front is going to make a vertical line. What kind of line? Yep, a solid one, because it's less than or equal to. And then we're going to shade for greater than or less than. Now this is greater than, and so for all of the other examples we have shaded up or down, and we've been very clear about that, that's up or down. But these are all for equations written in slope-intercept form. This is not in slope-intercept form. This has an x in the front, but it's the best we can do. So if x is greater than, this is the only time when we're going to shade right or left. Because if this is the x-axis, and it is, greater than is to the right. Okay, so an inequality with no y is the only time that we look right and left of the line. And of course, be checking our work. This is 0.00. 0 is the x. Is 0 greater than -4? Yes, it is. Good. All right, that is the end of that. See, it's not anything more difficult. It is difficult math, but it's just putting together another small, subtle difference. So let me switch gears here for you. Okay, here is your practice. So I'm going to zoom in a little bit. Hang on. Blech. Okay. So here, this is getting you in the habit of checking your work. It's asking for if 0, 0 is in the shaded region of all of these graphs, if you were to graph them. You do not need to. So x is greater than -4. The x part is 0. Is 0 greater than -4? Yeah, it is. For this section here, it's asking for this inequality. Is this point in the shaded region? And then separately, is this point in the shaded region? And this is not one or the other. This could be a yes and a no, 2 yeses, 2 nos. You're treating them separately. So again, this is x and y. And this is x is greater than 4. Is 3 greater than 4? No. So then we look at the other one separately. Is -1 greater than 4? No. And that's how that section goes. Okay, number 15 through 23, you're going to graph the inequality. If it's not already in slope-intercept form, you'll need to write it in slope-intercept form. And I would like for you to please write the equation that you're graphing. So for example, this one would be y is less than or equal to -5. And then on your coordinate plane, so you just did 21. y is less than or equal to -5. That is a horizontal line that is solid. And because it's less than, I'm going to shade down. Okay, sorry, I'm zoomed in a little bit too much right now. Okay, and number 24 through 26. Similarly, this is where you go the whole way through. So write these in slope-intercept form, graph them, make sure if you multiply or divide by a negative that you flip the sign. Make sure that if it's a less than or greater than, you use a dashed line, and make sure when you're shading, you shade up and down, not left and right. Okay, it's a lot of subtle things, but I'm sure you can do it. If you get stuck, don't hesitate to contact me. I'm always happy to help. Thanks, guys. I'll catch you in class. Bye.